Hi friends, this is Nivita. In this video, I am going to share one important theorem which is on ordinary differential equation, which will be coming for m.sc mathematics. Okay, so it is like a formula for Wronskian. Okay, here the theorem statement is if phi1 and phi2 are the two solutions of L of y is equal to 0, L of y equal to 0 at an interval I containing a point x0, then w of phi1 comma phi2 of x is equal to e power minus a1 into x minus x0 into w of phi1 comma phi2 into x0. So what they are telling is phi1 and phi2 are the two solutions for this equation. Okay, and there is an interval. In that interval there is a point named x0. Then suppose if all satisfies, means then we can substitute, instead of Wronskian we can substitute this. Okay, in many problems by using this formula we can just away solve that problem. It is true, in many problems we can just away solve that problem. Okay, we are going to see this formula derivation as a theorem. It is very easy theorem only. Okay, so given that phi1 and phi2 are the two solutions of L of y is equal to 0, what I am going to do, actually first what is the equation for L of y? It is a second order differential equation because they have given two roots, right? So we are going to write a second order differential equation. So L of y is equal to y double dash plus a1 into y dash plus a2 into y is equal to 0. After that, they have already given phi1 and phi2 are the solutions. What we need to do? We need to substitute, instead of y we need to substitute phi1 and phi2. Okay, as different equations. So we are doing phi1 double dash plus a1 into phi1 dash plus a2 into phi1 is equal to 0. After that we need to substitute phi2 instead of y. Okay, so phi2 double dash plus a1 into phi2 dash plus a2 into phi2 is equal to 0. Okay, so we have just substituted because they have given that these are the two solutions. Then what we are going to do is we need to find one equation. Okay, so I am going to solve this equation. For solving this equation, what I am going to do is, in this second equation I am going to multiply by minus phi2. Okay, so by multiplying this into this is here minus phi1 double dash into phi2. Then I am going to multiply minus phi2 with this term. Then I will get minus a1 into phi1 dash into phi2. Okay, after that I am going to multiply this term here. So then minus a2 into phi1 into phi2 equal to 0, right? So equal to 0. Then next step what I am going to do is, in the third equation I am going to multiply by phi1. So phi1 into phi2 dash plus a1 into phi1 into phi2 dash plus a2 into phi1 into phi2 dash. Okay, here not as phi1 dash, it is only phi1. Okay, so I am going to do the elimination process. So here can you see minus a2 phi1 phi2, here plus a2 phi1 phi2. So I am going to cancel those two terms. After that I will be getting minus phi1 double dash into phi2 plus phi1 phi2 double dash. In this terms a1 is constant, right? So I am going to bring it as a common term, a1 into phi1 phi2 dash minus phi2 phi1 dash is equal to 0. Okay, so I have just cancelled these two terms and I have just written these four terms into order. Okay, after that we can rewrite it as here the negative symbol is in the starting side, so I'm just reordering it. Okay, So then phi 1 into phi 2 double dash minus phi 2 into phi 1 double dash plus a1 into, I'm just writing this term here, is equal to 0. Okay, I'm marking this equation as equation number 4. Then we already know that Wronskian, Wronskian, we will be writing as W is equal to W of phi 1 minus phi 2, which we can write it as determinant of phi 1 dash, phi 2 dash. Okay, so finding the determinant, we will be getting phi 2 dash into phi 1 minus phi 1 dash into phi 2. Okay, we have written this expression here. So, and I am just marking this expression as fifth equation. Okay, then what I am going to do is, this is small w, what I am going to do is, I am going to differentiate that equation. Okay, simple. So, y dash is equal to, we know that the formula for the differentiation, uv, which is equal to uv dash plus vu dash, right? So in the first term is u and the second term is v. So here u v dash. So v dash means we are going to differentiate this. So then phi 2 double dash, we will be getting phi 2 double dash plus then v into u dash. So here v means phi 2 dash, u dash means phi 1 dash. Okay, so after that I am going to do differentiate for this term, and I am getting minus symbol here, and I am just differentiating and just keeping it as u and this as v. Then u v dash, right, plus v, this is v, u dash means phi 2 dash. Okay, I have just written like this, and in the next step I am going to bring this minus symbol to both the terms. So then I have written this two times as it is, then minus phi 2 into phi 1 double dash, then I am bringing this minus symbol here, so minus phi 1 dash into phi 2 dash. Okay, so I am going to cancel two terms, because here it is phi 2 dash into phi 1 dash, and here minus phi 1 dash into phi 2 dash. So I am just cancelling. So the remaining terms are phi 1 phi 2 double dash minus phi 2 phi 1 double dash. Okay, this is w dash, and I am getting this equation, and I am getting this expression. Okay, so what I am going to do is, I am going to substitute 5 and 6 in fourth equation. So what I will be getting, instead of this phi 1 phi 2 dash minus phi 2 phi 1 dash, I am going to substitute as w. Okay, just w, and instead of phi 1 phi 2 double dash minus phi 2 into phi 1 double dash. Okay, so here we have the expression as the same, so we are going to substitute, instead of this we are going to substitute as w dash plus a1 into w is equal to 0. Can you get my point? We have done nothing, just we have find out that equation, already find out that we have found that equation, and we are just substituting the Wronskian condition. Okay, and Wronskian condition, and also the differentiate equation of the Wronskian condition in this equation. Okay, then I will be getting this equation, right? W dash plus a1 w is equal to 0, and this is our first order equation. I am going to solve this equation. So instead of w dash, I am putting dw by dx plus a1 w is equal to 0. After that, I am bringing this equation, this term this side. So dw by dx is equal to minus a1 w. I am going to integrate, then only I will be getting w, right? So while integrating, before that I need to separate the terms as a variable separable method. So I am going to put this w here and dx here. Then dw by w is equal to minus a1 into dx. I will be getting like this. Okay, so we need to integrate both sides. We know that integrating 1 by w, we will be getting log w. Okay, so log w is equal to minus a1 integrating dx, we will be getting x plus c. Okay, then I need to get w, right? So I am taking exponential on both sides. So what I will be getting is e and a log will be cancelled. So w is equal to e power minus a1x plus c. Okay, here I will be getting minus a1x plus c. After that, in exponential, I am going to write c as a individual term, that is e power minus a1x plus c. So I am going to write it as e power minus a1x into e power c. Can you understand? So when the exponential power has a plus term, we can write it as a individual terms by a multiplication symbol. So that is what I have done in the next step. After that, e power c, the value of e power c is c. I am just substituting it as c. So then w is equal to c e power minus a1x. Okay. After that, what I am going to do is finding the value for c, I need to substitute x is equal to x naught. Okay. Instead of x, I am going to put it as x naught. So Wronskian of w of x naught is equal to c e power minus a1 x naught. Instead of x, I am putting x naught, right? Okay. After that, I need to find the value of c. So I am bringing this term this side. So c is equal to w of x naught into e power a1x. I will be getting a positive term only, because here it is minus. When we move that side, it will convert that into positive term. So e power a1x. Okay. So I am going to substitute this in 7th equation. Okay. So what I will be getting, w is equal to, instead of c, I will be getting w of x naught e power a1 x naught. Here I will be getting x naught only. Okay, because there it is x naught no. So when it goes to that side, I will be getting e power a1 x naught. Okay. Then what is the remaining term? E power minus a1x. E power minus a1x. Okay. So here what I am going to do is, here e and e are common. So I am going to write e, and a1 are common. So I am going to take minus a1 as a common term. So minus a1, then I will be getting x minus x naught. Okay, x minus x naught. This completes the theorem, because this is what the equation I need to get, right? The first step itself we have seen w is equal to w of x naught into e power a1 into minus a1 into x minus x naught. So it is a very useful theorem, because sometimes we can't find this value. So instead of this, we can substitute a point, okay, Wronskian point, and e power minus a1 into x minus x naught. Just like that, we will be getting the problem will be solved very easily. Okay, so this is a portion for ordinary differential equation. Thank you for watching.